Hey there! So we started playing around with streaming. Great. This is a completely different set of scenarios than batch processing. And what we did so far was to ingest the data into Azure Event Hubs. But right now, this data, those events, just sit there. They are not used, they are not analyzed, they are not processed. So they are basically useless. And what we would like to do is to analyze them in real time, detect patterns, find some outliers, some strange behaviors. That's the goal of streaming. And fortunately, in Azure, there is a service that will help us achieve this. And this service is called Azure Stream Analytics. And that's the topic for today, so let's get started. All right, so let's focus on processing the data. See what we can do with the data that has been already ingested into Azure. Now, let me start with drawing this general architecture diagram to help you position Stream Analytics on the landscape. So, let's say we've got some data sources, some IoT devices. And this star I see in documentation from Microsoft that's how they depicted IoT devices. So let's reuse the same icon. Or maybe we've got some logs data as a source. Or maybe we've got some streams that we would like to process. Anyway, the point here is that we've got some source data that is constantly producing data, those events, that we would like to process right now without any delay. This is streaming, not batch processing. And we know from the last episode that first of all, we've got to ingest this data into Azure. And basically we've got two choices. Either we use Event Hubs or IoT Hubs, depending on the source data. So in case of IoT devices, we would use IoT Hub, which we'll not do throughout the discourse, but there is this possibility. So actually, let me draw this on our diagram. And I will try to use this official icon of IoT Hub that I've never used. So we'll see how it goes. It's something like this. Oh, come on. Doesn't look that well. Let's say that this is IoT Hub. That's one of the places to which we can ingest the data. In case of big data, workloads, this type of solutions that we are working on, we would use Event Hubs, the second type of Azure ingestion service. And it is something like this. So this is Event Hubs. Event Hubs. And we know that the data would flow something like this. And we did the lower scenario the last time when we had this cool Event Hubs generator application written by Kamil, a really smart fellow, that sent some data to Event Hubs, but this data was not processed there. And that's the point for today. So the next step, what we would like to do, will be to grab this data from Event Hubs and process it, analyze it, detect some patterns or unusual behaviors. And I think the service to use would be Azure Stream Analytics. Azure Stream Analytics. All right, so it would be like this. And if you were to provide some captions to our phases, it would be like this. Here we've got data sources on the left. Then IoT Hubs and Event Hubs, it would be our ingest part. And Azure Stream Analytics could be used for analysis or analyze. Alright, so that's how it would look like. That's where Stream Analytics can be positioned. And obviously outputs from Stream Analytics, the stuff that we processed, would be saved to some other places, maybe multiple ones. Maybe it would be Power BI. Or maybe you would like to save it to Data Lake. Or maybe to database. Or any other output type that is supported by Stream Analytics. And we'll get back to this today. Alright. So we know that Stream Analytics fits here. But actually, what is this service? How does it look like? So, as always, what I suggest is to go into documentation and read the first few sentences about some service. And I have documentation about Azure Stream Analytics opened here. And let's read this stuff. So, it's like this. Azure Stream Analytics is a fully managed stream processing engine that is designed to analyze and process large volumes of streaming data with sub-millisecond latencies. Alright, so what does it mean? In simple words. So first of all, it is fully managed service. It means that, well, we don't have to bother about provisioning any infrastructure or hardware. No, we just deploy Stream Analytics and we start using it. So it's very simple to be used. No infra is in the landscape here. Secondly, it is a stream processing engine. So obviously that's what we want to do. We want to process our streaming data. It is designed to analyze and process streaming data. Yes, that's our point. We want to see what is in our data. We want to do something with it. And it can support large volumes of data. This is exactly what big data is. Large volumes of data that we want to process. And finally, they say that, well, it has quite good performance, this sub-millisecond latencies. And again, that is something that we want to have in Stream Analytics or in stream processing, especially if results have to be available instantly without any delay. So it looks that Stream Analytics is really a good service that can fit very well into our scenarios. Now, if you go through this documentation, you will find also some nice capabilities or feature or benefits of Stream Analytics, some of which are as follows. So it is very easy to use, and really this is true. I know that Microsoft says that every service is easy to be used, but in this case it is a really straightforward service, and you will see that in action that you should be able to start working with it within an hour. You should be prepared to do something with it. Secondly, it supports multiple output types, which means that when we did some processing in Stream Analytics and you want to save data somewhere, not only send it to Power BI, well, Stream Analytics can supports multiple different outputs like databases, Azure SQL, like Azure SQL DB, data lakes, blob storage, and some other ones, Azure Functions, Event Hubs, and so on and so on. So pretty good set of services to which we can send the processed data. Then you should remember that when I was talking about Event Hubs, I talked about those checkpoints. That, well, data from Event Hubs, they don't disappear after they are read by some consumer. And in this case, Stream Analytics is a consumer that is reading data from Event Hubs or IoT Hubs. And it is the responsibility of the consumer to know what data it read, what data it processed, this checkpointing process. And the nice stuff about Stream Analytics is that it is handled for us. You don't even have to bother about this because it is built into the product. And finally, it nicely integrates with machine learning, which means that you can use out of the box some machine learning functions, for example, to detect some unusual behavior, like sudden spikes or dips in the data. For example, let me draw something. What I have in mind. So let's say that this is our data. Something like this. It doesn't really matter what kind of data it is. And this is the usual values that are processed. And then suddenly we've got this spike. And then it goes back to normal. And maybe somewhere next time we've got this dip. And what those machine learning functions will allow us to do would be to detect this unusual behavior. Because that's what machine learning is used for, to detect, among others, those anomalies. All right. So if Stream Analytics is so cool, so let's create one and let's see what we can do with it. So let's jump to Azure portal and let me create Azure Stream Analytics job, because actually the stuff that we will be creating is called Azure Stream Analytics job. So if we start typing Azure Stream Analytics and oh, come on. Sometimes this search, oh yeah, there is Stream Analytics jobs without Azure. Sometimes there is Azure in the name, sometimes there isn't. So let's create new Stream Analytics job. Because the unit of, or the thing that we want to provision is called Stream Analytics job, even though the service is called Stream Analytics. So let me create a new one. And as always, we have to provide some details like where we want this job to be created. And let's use our DP203 resource group, the same one that we've been using so far. Let's give a name to our job, like demo job table. Let's give it a region of West Europe. Hosting environment, let's ignore it. Let's set it to cloud. We've got this streaming unique details, and you should have a clue already what it might mean, that it has something to do with the processing power of the job. And as they say here, streaming units represent the computing resources that are allocated to execute a Stream Analytics job. Basically, how powerful and how expensive your Stream Analytics job will be. Now, for this demo, I will move it to the cheapest version, 1/3 of the streaming unit. And I guess that's all that I have to set. Actually, let me revisit these options. Yep, that's fine. So let me create this Stream Analytics job. Now, it should be created within a second. And in the meantime, oh, actually it was created already. So let's jump into the resource. And now, what can we do here? The first thing that is important is this job topology. That we've got some inputs, we've got some outputs, and we've got the query. Those are the three most important elements of our job. So actually, let me draw this. So let's say that here, this big black rectangle, this is our Stream Analytics job. The stuff that we just provisioned. Stream Analytics job. And basically this is this part from the diagram, just a bigger picture. All right, so how does it look like inside? So, well, if we want to do something with the data, we want to analyze it, then first we've got to indicate, all right, where is this data coming from? So we've got to define some inputs, and that's the first part of the job that we'll usually do. So we want to configure inputs. And the nice thing about Stream Analytics is that we can have multiple inputs defined. Usually we would use only one, but there is a possibility to use multiple ones. So what type of inputs we can have? Well, the most obvious ones are Event Hubs. Event Hubs. And that's what we'll use today. Apart from that, if you are dealing with IoT stuff, then you would use IoT Hub. And there are also two other options that could be used, which is data from data lake, so ADLS Gen 2, or data from blob storage. Blob storage, so a regular storage account. All right, so inputs will define where the data is coming from that we want to analyze. And in our case, we would use just Event Hubs, the one that we've been using previously, the one to which we will send data from this event generator. All right, so that's one thing of the job. On the other side, we'll have to decide, all right, where this data will be saved. So we'll have some outputs. And again, a very cool thing about Stream Analytics jobs is that we can define multiple outputs. So we can have not only multiple inputs, but also multiple outputs. For example, we can have SQL database. We can have data lake. And we will use today data lakes because it will be very easy to observe the data that is processed by and returned by Stream Analytics. We can have Power BI. We can have Event Hubs. And some others. You will see all the types in a second. All right, and what is missing here is the middle part, the most important one. Namely, how do we process the data? What do we have to do to process it? And basically, this is what query is. So inside our Stream Analytics job, its main part would be query. And our query that we'll write will simply connect data from the inputs, do something with it, and send it to outputs. So actually, let's move it to the middle. And now, again, yet another cool thing about those queries is that they are written in SQL-like syntax. So if you know SQL, and you really should as a data engineer, then writing those queries would be very easy for you, because you will be able to write them within an hour or so. So pretty easy stuff. Obviously, because we are dealing with streaming data, there will be required some special additions to regular SQL that will allow you to handle this streaming data, but we'll cover that in a second. If you would like to, you can write your own functions or aggregates using JavaScript. If the stuff that is built into Stream Analytics is not enough, go ahead, write your own code. JavaScript. And there is also some limited support for C#. And I say limited because it is already marked as maybe not deprecated, but it will be deprecated very soon. So don't use C#. All right, so let's do this. Let's try to create a very simple job. And to make this work, let's see what kind of data we would like to analyze. So again, I'm using this real-time data simulator by Camille that I updated a bit the payload on this window, because let's see how the sample event will look like. It's like this. So basically, let's imagine that we are still working in a case when I've got these YouTube episodes that are published for you, and you have a possibility to score every episode. And those events that we receive are your scores. And the body of those events would contain data as follows: the time when the score was created, the score, actual value, between 1 to 5, and identifier of episode that you just scored, between 1 and 50. So that's the data that we will have. And in a second, we would like to start analyzing this data to see how this data looks like. All right, so let me run the tool just to send some data to our Event Hubs. And I already configured it in a way to send the data to proper Event Hub. So it should be working just fine. So let's revisit our Stream Analytics job. And let's create those inputs, output to a data lake, and then our query. So where is our job? It's here. And by the way, there is also this no-code editor available that allows you to write the query in a visual way. I am not a fan of this solution, but it exists. Later I will show you how it might look like. Alright, so let's start with defining inputs. Because inputs, it determines what is the source of the data. So in our case, we would like to use Event Hub as a source. And please note that we've got those sources that I just covered: data lakes, storage account, Event Hubs, IoT Hubs, and also a preview of Kafka. That's for streaming input. But apart from that, we've got a reference input, which can be an SQL database or data lake / blob storage. So what is this reference input? So take a look at our sample data. So what we have here, in our case, is this episode ID that will allow us to identify an episode that was just scored. But what if the output data, I would like to have this episode name, not the ID, just to make it more user-friendly. And the thing is that, well, that's the great candidate for the reference data, for static data, for those dictionaries that might be defined somewhere else, not in the stream data, because we don't need this information in the stream data. I mean, ID is enough, but we would like to combine those two data sets together. And this is what this reference data is. So apart from those regular streaming inputs, so this is stream, we can have a reference data. Or static data. And usually it is used just for lookup purposes, just to use some user-friendly name instead of some identifiers. And here it could be either SQL database or data lake or blob storage. And we could define it as well, and then we could join those data from those various data sets together, and in the output, instead of ID, we would have this nice user-friendly name of the episode. I will not do this today, but I would like you to know that such possibility exists. Alright, but let's finally define our Event Hub input. Oh, come on. So, first of all, let's indicate what Event Hub we are talking about. And it was this DP203 Event Hub stable. That's the one. Let's give it a name. My first Event Hub. It can be like this. Then we've got to define how we are going to connect to it. And by the way, this name was taken from our Event Hub name, because this was the name of the namespace of the logical container for our Event Hubs. But we want to connect to a specific Event Hub. That is called my first Event Hub. And actually, if we jump to Event Hubs, that's the one. That's the one to which the generator is sending the data, and we want to connect to it, well, to read the data from. Alright, then you should remember that we have those consumer groups inside Event Hubs. Basically, they define all downstream application. And I will just use existing group, the one that is created by default, called, well, default. And now, depending on the pricing tier of the Event Hubs, the number of consumer groups, it differs. But here we'll go with default one. Then we've got to define how we are going to connect to the Event Hub from Stream Analytics. And you know that we could use those access policies, like here, if we use connection string as the authentication mode, then we can define, or we can indicate which policy should be used. But actually here, I don't want to use policies. I would like to use managed identity. I would like it to be more secure. So how it will work? Let me draw it. So we'll be connecting to our Event Hubs. This one, that's what we are defining right now. And it was like this. Here, as a source for Event Hubs, we've got this event generator application that was configured in a way to send events to Event Hub. Now, this event generator, it also had to somehow authenticate to the Event Hubs, and in this case, we used those policies. Policy, and then we created a policy that allowed the generator to connect. And it had to be granted these send permissions. And actually, you should be able to see this in the Event Hub. We've got those shared access policies. And we created this send policy that allows someone who knows the connection string to send the data to the Event Hub. And in case of this generator, it was fine to use this because it was some external application that actually doesn't have an identity. But here, in case of this connection, the situation is different because both Event Hubs and Stream Analytics, they live in the same Azure subscription, in mine subscription. And Stream Analytics, it has its own identity. It has its managed identity that we could use to grant access to Event Hubs. And that's what we are going to do. So basically, that's the second way we could use to authenticate and be authorized to Event Hubs. Simply use role-based access control. There are some built-in roles that will be used here. So let's jump back to Azure portal, to our job. And what they say here is that if we use managed identity of the Stream Analytics job to connect to Event Hub, then this Azure Event Hubs data receiver role will be granted to the managed identity of our Stream Analytics. That will grant all the accesses that are required to read the data. And that's fine. The rest of the stuff is fine. The data that we send to Event Hubs is JSON, so everything should be fine. So let me save this, and hopefully our input will be properly created. And now the input has been created. It is being validated right now. If everything is working fine, hopefully it will be. Those permissions will be propagated. And what we could do would be to go to the Event Hub and verify what permissions were granted and to whom. And we just got a pop-up that permissions are still being propagated. So it might take a minute or two before it will start working. So actually, let's jump to Event Hub and let's use this second authentication option, role-based access control, to see what permissions were granted, what are the roles assignments. And hopefully we would see, yep, that our demo job table, that's the managed identity of our Stream Analytics job, has been already granted this Azure Event Hubs data receiver role. So permissions wise, everything is done. Now, in real life, I would probably update those permissions and use a dedicated Entra group that would be granted the permissions, and then I would insert this managed identity to the group. But for this exercise, this is fine. So actually here we could test if the connection works. So let me click this. By this time, all this propagation should be already finished, and in a second we should see this green check mark that everything is working fine. And there is. The connection is working just fine. So we've just defined our input. All right. So the first part is done. Now let's define the output to a data lake, because I would like to save the data that we are processing to our data lake. And we already have a data lake, this table data lake demo one. That's the one that we've been using for a long time. And inside it, we've got the curated container that right now has this replicable directory. So let me create a directory called YouTube. And here into this YouTube directory, we'll be saving data that was processed by Azure Stream Analytics. So let's create this output. And here, take a note how many different types of outputs we can have. Like to signups to a database, to data lakes, to event hubs if you want to chain the processing, to Power BI, to regular database, and some other ones. The one I want to use right now is a data lake. So again, let's indicate which data lake I want to use. It is this table data lake demo. Then which container I would like to use, and I would like to go with the curated one, because that's where our data will be saved, into YouTube directory. And let's give it a name like, actually, here we will use multiple outputs. So we would have to make sure that their names are meaningful. And the first case I would like to show you would be a very simple pass-through scenario, when we will simply just receive all the data from the Event Hub and just dump it to a data lake without any changes. So I will call it pass-through output. Can I have big names? We'll see. And let me change the authentication mode from connection string, which uses storage account key, very bad thing, don't do this. And here I will also use managed identity. And here what the tooltip says, that it will grant storage blob data contributor role. Alright, the role is correct because we need permissions to write. And in a second we will see how it was granted, on which object. Then, how do we want to save the data? Which file format? In real life, I would go with Delta Lake most likely. But today, I will choose JSON because it will be easier just to view the contents of the generated files. So let me go with JSON. Format and encoding is fine. And what I would like to configure as well is our path pattern. So basically where in the container this data will be saved. So we know that it has to be saved into YouTube directory. And then what is nice, actually it should be the other way, this way. What is nice is that we can use data from our events as part of the path. So again, inside our payload, we've got this episode ID, identifier of the episode that has been scored. And actually, I would like to partition my data on a data lake by this episode ID. So I want to have separate directories for each episode. So that's why I will use this episode ID value inside this path pattern. So let me call it YouTube pass-through output, then slash, and in curly braces, let me insert this episode ID, which will tell Stream Analytics that this is the data from events, and it will be replaced with actual value. Alright, and everything should be fine. So let's save it, and let's see if this output will be properly created. Hopefully it will. And again, please note that in this case, we also used managed identity for authentication purposes, which means that we are following best practices. We are not hard coding any passwords and secrets in the code. No, it is handled automatically by Azure. And now this output will be created, and in a second we should be able to verify if everything is working fine. So let me use this test button to see. At this time, maybe it has not been propagated yet, but we'll see. At the same time, we can go to our data lake and see how the permissions were granted on the curated container. So how the access control looks like. Is there an storage blob data contributor role? And take a note. Yes. Our managed identity of Stream Analytics job has been granted a storage blob data contributor role on this container. So not on the whole storage account, but on this particular container. And again, in real life, I would probably modify this a bit to use our Entra groups that we created previously that grants access to the data lake. But for now, let's leave it as it is. Alright, and in the meantime, it has been verified that the output is working fine. So we can now go to the most important part, to create the query. Because right now we've got our input, we've got our output, and the last part is to create the query. So query. Now, by default, when you open this this window, what you can see here in the middle is this pane where you will be defining your query. And out of the box, it creates this very simple pass-through query that simply grabs all data from your input and dumps it to your output. On the left-hand side here, you can see all the inputs that you've defined. Right now we've got only one, our My First Event Hub, that points to our Event Hub. We've got a single output that points to this pass-through output directory, and that's it. At the bottom, you can see preview of the data that was read from the input, in our case from the Event Hub. And actually, for start, that's what we want to do. Just grab all the data from our input, from our Event Hub. Don't do absolutely anything with it. Don't process it. Don't aggregate it. Don't group it. And simply dump it into our data lake. That's it. Just to see how it works. So we can test the query to see how the data would look like. And we see that, well, some data has been displayed. And we've got those columns that we saw in the generator and some other ones, but we'll get back to that in a second. So actually, now how to run this? So first of all, this whole job, Stream Analytics job, has been stopped at this moment because we were editing it, we were creating it. And to start using it, you've got to, well, start the job. So it will listen for any data from the inputs, from Event Hubs, and if there is any, it will process it. So let me start it from data from right now. So start. You could do the same from the Overview tab of Stream Analytics. Here you would see this Start Job option. And now the status is starting. It will take a minute to start the job. And in the meantime, let me start generating some data. So the job will have something to process once it starts. And the way our generator is configured is that, well, it will create 10 messages. Actually, I want to run it every second. So every second, it will send 10 messages to the Event Hub, and it will repeat the process 100 times. So in total, it would be 1000 messages sent. So let's run this, and let's wait a second until Stream Analytics starts. Did it start already? No, it's still starting. Alright, so I'll be back in a second. Alright, so the job is running, and I saw that it already processed some data. So let's see how the outputs look like on a data lake. So let's jump into this YouTube directory, then into this newly created passthrough output directory that was created by Stream Analytics. And inside we've got directories for every episode that was scored. And let's see how the data looks for episode 12. And we've got this JSON file. So let's see what's inside. And yes, we can see that every event is simply saved as a separate JSON object inside the file. And what data we can see inside is the publish time, so basically when it was generated. And this information comes from the event itself because it was included in the event body. Then we've got the score, some random value between 1 and 5, and the episode ID number. And please note that because we partitioned this data, this file contains only data for episode 12. But please also note that we also have some additional columns. This event processed UTC time, partition ID, and event and queued UTC time. And this data was not a part of the original events. So it was added somewhere in the middle of the process. But we'll get back to this in the next episode. Alright, so basically what we did right now was to simply implement the capture process. We just grab all the data that we receive and we dump it to a data lake. That's it. Nice, but there is no value in doing this, unless you want just to archive the data. So let's start doing something more interesting. Let's start to analyze this data. Let's start to check how the scores look like, which episodes you like and which you don't. So let me go to Stream Analytics job. Let me stop it, because if I want to modify anything inside it, it has to be stopped. And what I would like to do, well, I would like to analyze those scores. And now the thing about streaming is that those data sets, those streams, basically they don't have an end. Data is constantly created. So unlike batch processing, we usually don't want to run our aggregates over the entire streaming, because that's not possible. And what is usually done is that we are splitting the whole stream into smaller parts of some size, and we are running the aggregations inside on those smaller parts. So actually, let me draw this. So let's say this is our timeline. You've got some scale, maybe seconds, 0, 10, 20, 30, and so on. And let's say we got some events. Actually, let me make it bigger. So those dots are the events that were generated by the source. And what usually happens is that we split it into those windows. So those are called windows. And instead of running our processing on the whole stream, we run it on the window. For example, you might want to run some count or aggregation or whatever you do. And then you would just output the results calculated inside those windows. So how this could be done? So Stream Analytics, you know that it uses SQL-like syntax to create those queries. But it adds some window functions that allows us to work with time. They allow us to split the stream into those windows and then analyze them somehow. So let's say that, where is my job? Where is my query? So let's say that this is my query that I would like to run. So it is right now, it is a regular SQL query. So what it does is basically it is calculating number of scores and average score per episode. And it is also providing ID of this episode. It is just a regular SQL query, the one that you could run on Azure SQL Database or on SQL Server. But the thing is that, well, it would work on the entire dataset. It doesn't take those windows into account. So we've got to enhance it. We've got to add those windows. And actually, we've got five window functions that we could use. And I would like to talk a bit about them, how they work. And we'll see them in action in a second. So, windows. Very important stuff when we are working with Stream Analytics and data. So the first type of window is called Tumbling window. And this name should ring you a bell because somewhere we saw this tumbling word. I hope that you remember where it was. So in the case of Data Factory, we had this tumbling schedule that worked in a way that it simply executed the pipeline. It triggered the pipeline every specific set of minutes or hours. And we have something similar here. So let's say that this is our timeline. Let's say in seconds. And it looks like this. We've got some scale. So this is the start of the time. 10, 20, 30, 40, 50, and so on. And then we've got some events that were produced by some source system, those purple dots. And let's say that they were produced as follows. And what we would like to do would be to split all this stream into windows of equal size. And this tumbling window does exactly this. So in the case of tumbling windows, we are splitting the entire stream into windows of equal size. Let's say we would like to set a window size of 10 seconds. So it would basically split all the data as follows. And then our query would be run on those windows. So in case of the first window, this one, it would run on those two events only. The next one would run on this event, and so on and so on. And the most important stuff about tumbling window is that basically those windows that we created, we split the whole timeline, the whole data set into those windows. They don't overlap. So there is no overlap. as you can see, there are also no gaps between those windows. As a result, it means that, well, there is one-to-one relation between event and the window. Simply put, a specific event, like this one, it will be processed only in a single window. In this case, in this one. And now, so how to use this function? So basically, you would write your SQL query. So select something, 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 and then you would add group by maybe some columns, like by episode ID, and then by tumbling window. That's the keyword that you've got to use. Tumbling window. And then you have to indicate, alright, so how big those windows should be. So first of all, you would provide a time unit. In my case, it would be seconds. So second. And the second parameter would be actual value, like how many seconds. In this case, it would be 10. So basically, this value is the size of the window, like so. So, alright, great, but what's the point of doing this? Well, let's say that I would like to analyze those scores, and I would like to know average score of every episode every 5 seconds. And that's where tumbling windows could be used. So actually, let's see this in action. So first of all, let me create a second output, because I would like to separate this data just to be able to quickly see how they looked like. And let me just copy this path, because we'll use something very similar. So let's add a new output to the same data lake, to the same container. So it was table data lake demo. Let's use existing curated container. Let's provide a path like this, but let's change the directory to tumbling output. And let's use this as the name of our output. And let me save this. And hopefully it will work. If the passthrough output worked, this one should work as well. And now, how to use this? We don't have to create yet another instance of the job. No, we just need to revisit our query, and we can add yet another select statement to it. And the best part is that Stream Analytics would process all of them. And you can see that we've got this new output available. And let me simply copy the query that I have prepared. So it is like this. Let me just update the sources. So the source is my first event hub, and the output is called tumbling output. Alright, so what I'm doing here. So I have basically the same select statement that I showed you some time ago. What I added is this group by. That's the most important part. It instructs Stream Analytics to split all data into windows of size equal to 5 seconds that don't overlap and there are no gaps between them. And those aggregations would be run inside those windows. I'm also adding this system timestamp column that will show us when this window ended. So what do I mean by this? Basically, those windows and their results, they are returned at the end of the window, so at this moment in time. So data for this window is returned at the end of the window. And this system timestamp, well, it will allow us to see when the window ended. And don't worry, we'll cover time in the next episode. So it should work. So let me save this query. And then, was it saved? So why is this grayed out? Sometimes the UI doesn't work very well. So let me start it from here. And let me also run the generator to generate some data, and I will be back in a second. Alright, and some data was generated by the job. It was saved to this Tumbling output directory. And we can see that it is still partitioned by the episode ID because that's how we configured the output. And let's see at data for episode 12, how it looks like. And here you can see that this time, take a look at the data. We've got this episode ID that tells which episode we are looking at. Then we've got this new column called window end time. And take a look at this data, that it is there is 5-second difference between each of them if there was any data generated. And then we've got those calculated aggregations, like how many scores were received within this 5-second window that ended at this particular time, and then what was the average score of this episode within this particular window. And if we refresh this, you can see that this data, some data is appended as new events are generated. So basically that's how Tumbling window works. The simplest window function for Stream Analytics that simply splits all data into windows of equal size without any gaps or overlaps. So let me stop the job because we'll be adding soon some additional queries. And let's take a look at yet another function. So the other type of function we could do, so function number 2 is called hopping window. And it differs a bit from the Tumbling window. And let me show you how it looks like. So again, this is our timeline. We've got some scale, like 0, 10, 20, 30, 40, and so on. Let's say that we've got some events that were generated at the various points in time. And we would use this hopping window to split the data into windows. But here the processing differs. Basically, in case of hopping windows, we will still have windows of the same size, but they might overlap. And usually they do, because that's the whole point of hopping windows. So let's say that we would write a query. It would be quite similar to the previous one. It would be something like select from and so on, then group by something like this episode ID, and then instead of Tumbling window, we would use hopping window. Hopping window. And here we've got to provide 3 parameters. First of all, unit of time. Again, in our case, it would be seconds. Then we've got to provide a size of the window, let's say 10 seconds. And then finally the hop size, 5 seconds. Alright, but how it would look like. So based on this data, we know that the size of the window should be set to 10 seconds. So the first window would be like this. It would be outputted at second 10 at the end of the window, and it would contain those two events. So the calculation, those aggregations would run on those two events. But then the next window, it won't start here like in case of hopping window. No, because we've got this hop parameter that says what's the hop or what's the delay. In our case, it was 5 seconds. So the next window would be like this. From second number 5 to second number 15. And in this case, what events would be included? Well, only this one, because only it falls within the range of the window. Then we would have yet another window from second 10 to 20 and so on. And here we would have this event, right? So basically the parameters are as follows. So this one indicates the size of our window, and the last one, it indicates the hop size or delay. And now, if you configure hopping window in a specific way, it would behave exactly as the tumbling window. But I leave it to you to figure it out how you would have to set those parameters to have the same behavior as in case of tumbling windows. And now, the most important things about hopping windows is that, well, those windows overlap, as you can see. Here we've got the part that overlaps, and then this one. So there is overlap. And when it comes to event to window relation, you can see that the same event, it can be included in multiple windows. So it is different than in the case of tumbling windows. So we've got 1 to n event to window relation. All right. So let's use this hopping window function inside our data. And looking at our data, this hopping window would help us to provide this value. Like every 5 seconds, I would like to know the average score of my episodes over last 10 seconds. So data would be still, data from 10 seconds would be taken into consideration, but I want to see those average every 5 seconds. So let's see how it could be done. So first of all, come on, we've got to create new output. Well, I want to create new output just to have them nicely separated. So let me copy the path. Let's add new data lake output to the same, it was stable data lake demo on our curated container. Actually, managed identity, it should be. Previously, I made a mistake and I used connection string, so bad for me. Let's provide a path. This time it is a hopping window. And let's use this as the name of our output. And you can see that indeed I made a mistake and used a connection string. I forgot to update it. So it should be fixed later on. So let's go to our query and let's add yet another select statement. And please note that all of those queries, this one, and the one that we'll just add in a second, all of them will be executed. not only the last one, all of them. So for hopping window, my query would look as follows. So let me just format it a bit. Let's organize the input, and the output is called hopping output. Hopping output. Oh, come on. Output. And it should be fine. And it is configured in a way that it would analyze data from 10 seconds every 5 seconds. All right, so let me save this. And it is still grayed out. So it is job ready to start, but somehow from this place I cannot start it. So let's go to overview. Let's start the job. Let's start generating some data. Actually, let's give it 200 batches. And let's wait a bit. And now you might be wondering, all right, but what's the point of this hopping window data? When it could be used? What's the point of doing this? And actually, some time ago, there was a very well-known data set available publicly that used this type of processing. And let me explain what it was and why it was done this way. So, oh, come on, let me move it so you can see what I'm drawing. So basically, I'm talking about COVID pandemic. When it hit, we were given those data about number of infected people. And it was done on a daily basis. So basically every day, those labs around the world, they provided data about number of positive test results. And they were aggregated and then made available publicly. And the thing is that data was made available on a daily basis. So we've got, so this is day on this axis, and here number of positive cases, number of sick people. And let's say that we've got Monday, Tuesday, then Wednesday, Thursday, Friday, Saturday. Actually, I have to extend the diagram a bit. Saturday, Sunday, and then Monday, Tuesday, and so on. And now, the thing is that the data was usually looking as follows. So let's say on Monday, it was quite big, number of new sick people. On Tuesday, it was this. On Wednesday, maybe something similar. On Friday it was this, and then suddenly on a Saturday and Sunday it was rather small. But then again, on Monday it was quite big, and it dropped on Tuesdays. So what happened? And this is real data. So basically the case was that those labs that were making the tests, they were working on Saturdays and Sundays, but this data was not made available during the weekends. So basically, data from weekends were returned on Monday. And that's why data from Mondays looked so different, so big. And if you would be just looking at the daily data without the wider context, you would be surprised that, oh, come on, we've got a big spike in number of infected people, because it just went high as hell. And then on Tuesdays, it dropped. So we are getting better, right? No, it's not the case. That's just the skew due to the way this data was processed. And actually, how the data was made available to the public was that usually numbers were aggregated over last 7 days. So it was like this. The first, oh, come on, I have to change the color. So on the first result set, it contained, let's say, aggregated data, average data from the whole week, from 7 days. So this sudden increase, it was taken into account together with the weekend. So the average was more realistic. Then on the next day, and this data was returned on, let's say, on Sunday. Then the next day, the data that was returned would contain those data. So again, data from last 7 days that is returned on a daily basis. Then the next day, it would contain this data. So as you can see, this is a typical case of a hopping window, where the size of the window is set to 7 days, but the hop size is 1 day. So basically, every day we got an average number of sick people from last 7 days. And this value, it allows us to know if the number of sick people is increasing or not. Because if we would be looking just at the daily values, then we could just make bad decisions. All right, in the meantime, our job has started. So on a data lake, we should see new directory for this hopping output. So let's see how it looks like for some sample a random episode. And yes, we can see some data. And take a look at those timestamps. That the difference between 2 consecutive windows is set to 5 seconds. Because that's how we set the hop size. But the actual data that was taken into account for each window, oh come on, it was data from 10 seconds, because that's how we defined our windows. Alright, so let me stop the job and let's move on, because we still have 3 more window functions to cover. So that was the hopping window. So let's move on to the sliding window, which is a bit more difficult. So sliding window. Sliding window. And this one, it allows us to answer, for example, this query. So please let me know if average score of an episode is bigger than, let's say, 3 within 20 seconds, but assuming that there were at least 3 scores. So that's a type of the question that could be answered by the sliding window function. I know, quite complex, but stay with me. I will try to explain how it works. So again, we've got our timeline, and it has some scale and so on. And now let's say that we've got some events. Let's say we've got an event here and we've got an event here. So the first event, it was created at the second 13, and the next one was created at the second 17. Let me move it a bit. So now, how does it work? So basically, in a sliding window, the window is created, or it outputs data only when the content of the window changes. In sliding window, we've got our window constantly moving, all right? And whenever its content changes, it produces some data. And its content changes whenever some event comes to the to the scope or it leaves the scope. So how it would look like on our diagram. So let's say that we wrote the query as follows: select something, group by something, and then we've got sliding window syntax. So sliding window. Then we've got to provide unit of time. Still it would be seconds. And let's say 10 seconds. So the size of our window that is moving is 10 seconds. And please note that the name of this function is called sliding window. We had this name in case of partitioning, in case of SQL databases or SQL dedicated SQL pools, but there are different things, so do not confuse them. So our windows starts to move. And now, when is the first time when the content of the window changes? So take a note. So this is, oh, come on, too thick line. So here, at second 10, is there anything to be outputted? No. So no data would be returned yet. So it is moved. It moves to second 11, still no data. Second 12, no data. Second 13, yes, something changes. Because then we've got this event that was created at 13th second. So we would have the first window, the first data on which those aggregations would run. It would be created at the second 13. And it would contain this event. So that's the first moment in time. Then it moves, second 14, nothing changes because we still have the single event in the scope. Second 15, no changes. 16, no changes. 17, yes, something changes again because we've got the second event. So the second window, oh come on, the second window that is generated would be from second 7, so something somewhere here, to second, let's say it is like this, to second 17. And it would contain those two events, right? Then our window moves, second 18, no changes, 19, no changes, 20, no changes, up to the second 23, when our first event, this one, it leaves our scope. Alright, so here, when it leaves the scope, yet another window would be generated that would contain only this event. So basically it means that our window is constantly moving, right, across time and data. And if there is any change in the scope, then the output is generated, and based on this output, our aggregations are calculated. So in our case, what we would do? Well, we would simply configure the size of the window to 20 seconds because we want to analyze data of 20 seconds whenever they start. And we want to know if there is an episode that got the average score, let's say bigger than 3, but only if there were at least 3 events inside. So we don't care about, let's say, this window because there's only one score and it's not enough for me to be happy that it got this nice score. So let me create new input, and sorry, not input, output. So again, let me copy this path. Let's add new output. This time I will remember to to use managed identity. And we want to go to curated. Yes, please use managed identity. Then as a path, we want to use sliding output. And we would use also this sliding output as the name of our alias. All right, so it is done. And then let's update our query to add yet another flavor of the processing. And let me quickly copy this. Oh, come on. It started to respond. Oh, this time it's working. So let me reformat it. And let me just fix it a bit. So we've got sliding output. Our source is called my first event hub. And it's like this. So what this query does? So it splits the data into those 20-second windows that are moving constantly. And I'm calculating, as always, number of scores and average score, but only if the average score is bigger than 3 within the window, and if we've got at least 3 scores within the window. So that's the goal. So let me save this. Let's run the job. And I'll be back in a second when this data appears. All right, and I can see that some data has been generated. So let's jump into this sliding output directory. Let's say number 16. What data do we have here? And take note that, well, we've got less data than previously. That's one, because we had these strict conditions. And secondly, those window end times, they are no longer that nice, like every 5 seconds. Because, well, in the case of sliding windows, you don't know when the window will stop, because it is determined by the time a specific event either appeared or disappeared from the window scope. And indeed, we can see that all of those cases, we have score count bigger than 3, as we wanted, and secondly, the average score is bigger than 3, which is nice. So exactly what we wanted to achieve. So let me stop the job and let me talk about 2 remaining window types. But this time I will not show them in action because this episode is getting quite long and I don't want to bore you. Alright, so function number 4 is called session window. So session window. And by the way, in the case of sliding window, this parameter, it indicates the size, as always. Now, for the session window, how does it look like? So we've got our time, and basically, in case of session windows, we are interested in those events that arrived at similar time. When we have a session, let's say there is a user who is clicking on a website and we want to track his activity. Or maybe in case of my data, there was some event, public event, that caused that multiple persons started to scoring my episodes. Maybe new episode was published and it just triggered you to watch it and score. So how does it look like? Well, we still have our time. We would run our query as select from group by, and here we would use group by session window. So session window, and we would have to provide this time 3 parameters. So the first one would be unit of time, let's say seconds. Then we would provide a second value, which is a timeout. In a second, I will explain what it means. And then the max duration, let's say 20 seconds. And let's say that I would like to answer the following question using session window. Please, Stream Analytics, tell me the average score of my episodes, taking into account scores that were made within 5 seconds of each other, but no longer than with this 20-second duration. Alright, so how does it work? So the first parameter, this is timeout, and this is max duration. Alright, and let's say that we've got events as follows. So the first event was in second number 3, which started the window. It opened it. And we've got this event. Now, because we defined the timeout to 5 seconds, what happens is that clock starts ticking from second number 3, and it waits for those 5 seconds. If there is no new event within this time that would fit into this window, so in my case it would have to be done for the same episode, then the window closes and the results are returned. But because in my case, oh come on, wrong color. In my case, in second number 7, new score for the same episode was generated. So it was just about time, because otherwise in second number 8 the window would close. But because new event was generated, it means that, well, we got again new timeout of 5 seconds. So it would wait for yet another 5 seconds to see if there is any new event that would appear, but it didn't. So after those 5 seconds the window closes and it would be used as a source for my data processing. But let's say that those events, they just keep appearing all the time, so there is never a moment in time where this timeout could happen, because they are so dense. And that's when this max duration parameter is used, because we defined that max size of my window would be 20 seconds. So after some time, even if there are still new events that would fit into my window, it would be closed and its data would be processed. So basically, a session window, it allows us to analyze the data that was produced, that was delivered at similar times, close together. So that's a session window. I will not run it in Stream Analytics. And finally, the last function is called snapshot window. So snapshot window. And this one is super easy because it works like this. We've got our time. And basically, it works in those cases when we've got events that were, it simply groups those events that were generated at the same time. So simply put, the first window would contain those events, assuming that they were generated at the same time. The second one would contain this one, then third one would contain this, and the last one would contain those, and so on and so on. And now a snapshot window on its own, it's rather rarely used because it's rather unlikely to have events that arrived at exactly the same time. more often it is used in conjunction with some other function. For example, first we would use tumbling window to group those events together, and then we would just use this snapshot on those events. So all events from the same tumbling window would have the same timestamp. So they would be seen by the snapshot window as the ones that arrived at the same time. I know, might sound complex, but that's the use case for snapshots. Alright, and basically that's it. I know it was the longest episode so far, so let me summarize it quickly. So basically, once we have the data available in Azure, in Event Hubs or in IoT Hubs, we would like to analyze them. We would like to process them. And because we usually are not able to process all data at once, we want to split it into smaller chunks and then run the analysis on those smaller parts. And the service that allows us it to do is called Azure Stream Analytics. In case of which we've got to define those input, output, and the query that combines those two things. And the nice thing about Stream Analytics is that, well, first of all, it uses SQL-like syntax, so it's pretty easy to learn it. And secondly, it allows us to use those 5 window functions that let us split data into specific windows. And that's it for today. Thanks for watching and see you next time. Take care.